Hi everyone, in this video I'm going to be talking about what is atomic mass and what is a mole. So we know how small atoms are and what exactly atoms are. Now let's talk about how heavy these atoms are, okay? So we know how every element is made up of its constituent atoms. For example, gold is made up of gold atoms. Now, if I want to know the mass of this gold atom, what I can normally do is I can just take a weighing balance and on top of that I can add a gold atom, and whatever mass I can get is called the atomic mass of the gold atom, okay? But one thing is very important to understand, that atoms are very small, unimaginably small, as we discussed in the last video. So let alone feeling them and touching them, we can't even see them, right? So we cannot actually see them, feel them and hold them and put them on a weighing balance and measure their masses because they are not macroscopic. We can't even see them. So we need a different way by which we can measure the masses of atoms, right? So in today's world, we have beautiful techniques. We have very advanced machinery, one which is called a mass spectrometer, in which we can exactly measure the mass of even atoms, okay? But this is what is today. This is the science of today. Many years back, we had scientists, okay, who had just one question: how do we measure the mass of atoms, something that we can't even see? But one thing I think everybody should remember, that knowledge is always superseding technology. So these scientists did not have technology, but they had one very important thing, which is their knowledge. So they applied their knowledge and they were able to find out the masses of these atoms. Let's see how. So we know what 1 kg is. 1 kg or kilogram is universally accepted unit for mass. So if something is 1 kg in India, let's say, it is going to be 1 kg in US, in Germany, basically everywhere worldwide, because it is a universally accepted unit for mass. So now, atoms are so small that their mass cannot be measured in units like kilograms, grams, milligrams, even micrograms, right? So that is why the need of the hour is we need a new unit, okay, which is going to be used for measuring the masses of smaller things like atoms and molecules. And because we are going to be measuring the mass of atoms, that unit is called the atomic mass unit, okay? So for example, if I take a weighing balance and if I add a ball onto the weighing balance and the weighing balance shows me 4 kg, it basically means that this ball is 4 times as heavy as 1 kg, and 1 kg is a standard. It is a universally accepted standard. So this ball is 4 kg or 4 times the standard weight, that is 1 kg. Okay. Now similarly in atoms, we need a basic universally accepted standard, and that is what the scientists were curious to know, what this standard could be. Now scientists did not know the mass of atoms, right? But they knew one thing, that hydrogen is the lightest of all the atoms. They knew that atoms exist. They knew that every atoms, different elements have different atoms, but they also knew that hydrogen is the lightest of them all. And because of that, hydrogen was chosen as the standard for measuring the masses of different atoms. So because hydrogen was lightest of all the atoms and all the atoms were heavier than the hydrogen atom, hydrogen was arbitrarily given the number 1 atomic mass unit. For example, 12 times the mass of hydrogen atoms is equal to 1 carbon atoms, okay? So mass of 1 carbon atom should be equal to 12 AMU. Okay. Similarly, mass of 1 nitrogen atom came out to be 14 AMU. Mass of 1 sodium atom came out to be 23 AMU. So basically, scientists, this was a huge success for the scientists of that time because they were able to now measure the mass of atoms. Okay. So just by knowing how heavy is another atom as compared to that of hydrogen atom, we can quantify them in their masses with respect to AMU or atomic mass unit. Okay. But it was later found out that hydrogen itself exists in 3 isotopic forms, which is hydrogen, deuterium and tritium. Deuterium is twice as heavy as hydrogen and tritium is thrice as heavy as hydrogen. Well, that was a very bad day for the scientists at that time, because now what they needed was a new standard, because our standard, our old standard, which is the hydrogen, is now not correct, okay, because now it itself is existing in 3 different forms. So we need a new standard, and the definition of 1 AMU, which is hydrogen atom, okay, initially it was hydrogen atom, should also change. After a lot of thought was given to this, carbon atom was then chosen as the standard, and now we had to somehow change the definition of 1 AMU, which was initially with respect to hydrogen atom, to now being with respect to the carbon atom. Okay, so now what we already initially know is that mass of one atom of carbon is equal to 12 AMU, which means mass of one atom of carbon is 12 times as heavy as the hydrogen atom, right? But because now carbon is a standard, we have to somehow standardize carbon. Standardizing means making it equal to 1. Okay, now how do I make this 12 equal to 1? Think. You can pause this video and think, how can you make this 12 AMU as 1, or what mathematical function can you apply? Okay, so I think what we can do is we can just divide both sides by 12, and by doing that we will be getting 12 divided by 12, which is equal to 1. And this, my friends, exactly is the definition of 1 atomic mass unit. So on the right hand side you see 1, which is equal to 1 atomic mass unit. Initially hydrogen was 1 atomic mass unit, now carbon is 1 atomic mass unit, but by making carbon as 1 atomic mass unit, what we have done is we have divided mass of one atom by 12 on the left hand side, right? So basically 1 atomic mass unit is exactly the mass unit equal to 1/12 the mass of one atom of carbon 12, and this, my friends, is a definition of 1 atomic mass unit. But you have to be very clear in understanding that atomic mass unit only talks about the mass of atoms. Okay, atoms is something which we can't see, which we can't feel, which we can't touch. An atomic mass unit talks about the mass of those species which we can't see, feel and touch. Okay, now, so we basically have two kinds of worlds, right? We have this world in which the atoms exist, which is very, very small, which we can't even see, unimaginably small. And then we have our world around us, which is the macroscopic world, which we can see, feel, touch, and everything around us, right? So here we have the mass in atomic mass unit, and here we have the mass in grams and kilograms, right? Basically, while working in laboratories and while actually doing the experiments, we cannot actually talk about an atomic mass unit, because we cannot talk about each and every atom. Okay, because we cannot see each and every atom. We basically can see matter around us, which is a cluster of many different atoms together, right? So that is why we need kind of a bridge. Okay, a bridge which connects these two worlds, the one which is atomic mass unit and the one which is in grams and kilograms, and that bridge, my friends, is called a mole. Now let us discuss what is a mole. So if I talk about atoms of carbon, if I talk about one atom of carbon, of course I cannot see it, okay? 2, I cannot see it. 3, 4, I cannot see, feel or touch it, okay? But if I talk about these many atoms of carbon together, I can not only see, feel and touch it, I can also measure their mass in grams, and it comes out to be equal to 12 grams, okay? So this number which you see on your screen right now is actually called a mole. So basically this mole is just a number, and it's called an Avogadro's number because Avogadro was the scientist who gave this number, right? It is nothing but 6.022 into 10 to the power 23, and just like 1 dozen bananas is equal to 12 bananas, similarly 1 mole of anything is equal to 6.022 into 10 to the power 23 of anything. Okay, it can be 1 mole pen, 1 mole pencils. Okay, but because this is such a very, very high number, we cannot talk about macroscopic things in such high quantities. Okay, we can only talk about things like atoms, which are not macroscopic, and because of this, this number is very, very extremely large. Okay, also it's very important to understand what is so special about this Avogadro's number and why 6.022 into 10 to the power 23 is the only number which is the Avogadro's number. So, well, this is a table in NCERT which you guys absolutely have to remember, and this table talks about the mass of various atoms. Okay, so hydrogen atom is having the mass of 1 AMU. Carbon atom is having the mass of 12 AMU. So basically it is talking about the mass of atoms, okay, something which we can't see, feel or touch. Okay, so basically, for example, nitrogen atom is having the mass of 14 U or 14 AMU. Okay, but if I take not 1, not 2, but 6.022 into 10 to the power 23 atoms of nitrogen, the mass is going to be 14 grams. So whatever is the mass in U, it is going to be in grams if I take these many number or Avogadro number of nitrogen atoms. Okay, similarly, if I take Avogadro number of hydrogen atoms, the mass is going to be 1 gram. Okay, if I take Avogadro number of carbon atoms, the mass, as you see in the last slide, was equal to 12 grams. Okay, so this is special about Avogadro's number because it basically acts as a bridge between U, or the atomic mass unit, and the grams, which is the gram atomic mass, which we basically use and on a daily basis. Okay, so this was all about what is the mole and what is the atomic mass. I hope you guys understood. Now you all can head off to EduRev, practice the test, read the notes for better understanding. Thank you so much for watching.